Hello students, today's agenda is to check homework. You will be working with inscribed circles and you will be able to do 8.5. Today students will be able to find measurements of triangle parts by using inscribed circles. And so we're going to see more than just the inscribed circles. So for inscribed circles, this is some information that we need. Inscribed means that it's inside of a triangle, basically, or sometimes other figures, but we're going to be working with inscribed circles in triangles. When you do the angle bisectors of each angle in the triangle, those are the angle bisectors, and I'm going to show you really fast, even though it's not the standard to be covered, about the construction for these angle bisectors. So that's called the incenter, where the three angle bisectors meet. That's called the incenter. It's the point where the three angle bisectors of a triangle meet. Okay. The incenter is equidistant from the sides of the triangle, which I drew here with green. Okay. So the distance is called in radius, and they are all the same measurement. And if you notice, I put it in green just so that you understand that it's this part. Okay, the in radius. Okay, so these are equidistant. Very important to know that. That's what we're going to be working with. The green parts are equal measurement. Also, because these are angle bisectors, it means that it cuts the whole angle into two equal parts. So these two angles are congruent. These two angles are congruent. These two angles are congruent. So how do you draw or construct those angle bisectors? Again, this is not the point, or this is not what we're going to be covering, but so that you remember or recall, we did this in Math 1D. And I'm doing it a little fast because, again, it's not the focus. Well, the way that you do the angle bisectors are by creating an arc. And I think it's closing on me a little bit. Hold on. You draw an arc. Then from that intersection, you'll draw another arc. It doesn't matter if you open it a little bit or close it a little bit more, as long as you're able to create this angle bisector. So by doing this, you're already cutting this angle into two equal angles. Okay. And you're going to do the same thing for all three angles. Again, if you want to practice, you can go ahead and do it, even though you don't have to. Okay, so you created an arc from here, then from each intersection you create a little arc where they both meet, and from here to here you're creating the angle bisector. Okay, so that means that this angle is congruent to this angle. So let me just do markings in here. Those are congruent. These are congruent. I need one more, and it looks like they're gonna be right there. Sometimes they're not so perfect if I don't have the tools, or if sometimes they open, but more or less that's where it should meet. And so this is my other angle bisector, meaning that it bisects my angle into two equal parts. Okay, so this angle is congruent to this other angle. And so by drawing those angle bisectors, I just found my, what do you call this? Incenter. Okay, this is the incenter. And that is equidistant, meaning has the same measurement going from here to the side, from here to here, from here to here, using the perpendicular line from this point down. I'm not gonna construct a perpendicular bisector, or maybe I'll construct one. Again, this is not the standard to cover today, but this is how you would draw a perpendicular line going through one point, which is almost similar to what we were doing with the angles, right? So you just do an arc that goes through the opposite side of that point, and then create two little arcs in here, and then the perpendicular line just goes through this intersection and the point that we, so that, and I should use a different color, that is called, of the circle that we're going to be drawing, that's called the in radius. Okay, in radius, it means that it's going to form the radius of the circle that we're going to draw in here. I think that if you do one, it should be enough, because it's going to guide you where to place it, but it should go almost there. It's not touching that side, so something went wrong. But that's how you do the inscribed circle. And so from here to where the circle touches the side, that's another in radius, and from here to there too. And all these three in radius are equal in measurement. Also, they form perpendicular, 90-degree angles, and they're the in radius for the circle. Okay, so these are congruent, they're the same measurement. These are congruent because it's an angle bisector. These are congruent because this is an angle bisector, and these are congruent because this is an angle bisector. Okay, now that we have that information, and let's do some examples. So this is going to be given, and I'm going to give you information in here, and this is what you're going to be answering. It says, if measurement of angle DAG is talking about this right here, is 35 degrees, and measurement of angle GAE is talking about this angle over here, we already know that they're congruent, is 3x plus 2. So 3x plus 2. What is x? So we know that they're congruent, they're the same, so 35 equals 3x plus 2. If we're adding, we're going to subtract 2 from both sides. 3x is equals to 33. And if we're multiplying by 3, the opposite is to divide by 3. And so x is equals to 11. So x equals 11 degrees. Then it says find measurement of angle GAE. So, well, we can just guide ourselves in here. GAE is this expression, 3x plus 2. So 3x, but instead of the x, we're going to replace the value of 11 already, which is, of x already, which is 11. Okay, so all we did is copy the 3. Instead of x, replace the value of x plus 2. 3 times 11 is 33, plus 2 gives me 35. As you can see, this measures the same as the other angle. So angle GAE, which is this expression, gives me 35. So yay, they're both congruent, so we got it. Okay, the other one says, if FG, meaning this green line, equals 17 inches, What is GE? GE is this other green line. Well, we already know that those are congruent, so we're going to say that that's also 17 inches. What about DG? DG, that's also the same measurement, because remember that the in-center is equidistant to the sides of the triangle. So that's also 17 inches. Since I can't really go up, I'm going to fold this part here so that we can solve the rest. If you need to look at the previous examples, just go back on the video, okay? Excuse me. Now it says in here, if measurement of angle DBG is this angle right here, and notice how I'm putting different markings because they're not congruent to this one, okay? Is 2y plus 4, so 2y plus 4. And measurement of angle FBG is this other angle right here, is 4y minus 22. And we know that they are congruent because this is an angle bisector. So we're going to say that to find y, we're going to make them equal. So 2y plus 4 equals 4y minus 22. I subtract 2y from both sides. It doesn't matter which one you cancel first. If you want to cancel for y, it's fine, but then you're going to end up with negative variables because this one is bigger. That's why I decided to cancel that. 4y minus 2y equals 2y minus 22. Since my y is here, I want to get rid of the 2 and the 22, but first is the addition and subtraction, opposite of PEMDAS. And so we're going to have 2y equals 22 plus 4 is 26. If I'm multiplying, the opposite is to divide, and so y equals 26 divided by 2 is 13. So y is equals to 13 degrees. Now it says find measurement of angle DBG. DBG is 2y plus 4, but we already know the value of y. We are going to replace it, so it's going to be 2 times 13 plus 4. 2 times 13 is 26 plus 4, and 26 plus 4 gives me 30 degrees. Okay, so that's the measurement of this angle right here, 30 degrees. Then it says find measurement of angle FBG. FBG is this other expression. So it's 4 times y, but we already know that y is 13 minus 22. 4 times 13 gives me 52 minus 22, and 52 take away 22 gives me 30. Yay! So this is 30, this is 30, so that means that it's correct. Okay? Okay, let's do some more examples. Let me see if I can zoom out. Not that much. Okay, so in here it says, in here we don't have the in-center, well, we have the in-center because these are, again, angle bisectors. Remember that an angle is cut into 2 equal parts. So this is congruent to this one, this is congruent to this one, and this is congruent to this one. Even if we don't have any information other than that, we know that this is the in-center and that it's equidistant to the sides. Okay? So it says, what do we know about point D? It's the in-center and equidistant to the sides. And when we say to the sides, it means to the sides of the triangle. Okay? Then it says, if measurement of angle ACB, that means the whole thing is 56 degrees. What is measurement of angle DCA? DCA CA is only this part right here, half of it. That means that that measurement is going to be half of 56, which is 28 degrees. Okay, so we can say that measurement of angle DCA equals 28 degrees. The next part, and I'm putting it up here because it's this section right here, says if measurement of angle ABD, looking here, ABD is talking about this section right here, equals 3W plus 7, and the next one says, and measurement of angle ABC, again, ABC. Now it's talking about the whole thing. So that's where we have to be careful. And that whole thing is 10W minus 26. So 10W minus 26. Okay, again, this part is only for this little section, this half of it. ABC, or this expression, is for the whole bigger angle. Okay, how do we find W? It says, what is W? Well, we can create and say that 3W plus 7 twice, right? Because I know that this is congruent to this one. That means that I have two of the same, 2 of the 3W plus 7. Again, why? Because this is only half. So if I put it once more in here, it's also 3W plus 7. Okay, so I have it twice. Equals this, because it's the two of them together, that's 10W minus 26. I start doing distributive property. Now that I have it all set up, let me go back here. I do distributive property. So 2 times 3W is 6W. 2 times 7 is 14. Equals 10W minus 26. Again, because this is 6W, this is 10W, I'm going to subtract 6W from both sides. And so 14 equals 4W minus 26. If I'm subtracting 26, I'm going to add 26 to both sides. Some people say, why don't I get rid of 14 instead of 26? Well, because then I'm not going to have anything in here. Remember that we're trying to keep variables on one side and numbers on the other. And so I'm going to have 4W on this side, and on this side I have 40. If I'm multiplying, the inverse operation is to divide. And so W is equals to 10. In here, so W is equals to 10. What is measurement of angle ABD? So ABD is this part right here. Okay, so it's 3W plus 7. 3, but W, we know that it's 10. So we put times 10 plus 7. 3 times 10 is 30, plus 7 gives me 37 degrees. And so in here, I'm going to put this as measurement of angle ABC. Okay. So what is measurement of angle ABC? Since we know that it's the whole thing, and this is the other one was half, we know that this is going to be twice as wide as 37. So ABC is 10W, but we already know that W is 10, right? We're replacing this W with 10 because the value is 10. So 10 times 10 minus 26. 10 times 10 is 100 minus 26, and that gives me 74 degrees. If you see it, and I'm going to do it in a different color just to check, okay? So measurement of angle ABC is equals to 74. If you notice, 37 plus 37, 7 and 7 is 14, carry 1. 3 and 3 is 6, and 1 7. So 74 is double 37. And so you have to be careful if they're giving you the measurement of only one angle, one small angle, and then the total, then you have to multiply this by 2. Okay? But if they're giving you one angle and then the other, then you don't need to multiply. You just say this equals the expression of the other. Okay, so this is it. That's all about angle bisectors. They create two equal angles, two equal angles, two equal angles. They meet at the in-center, which is equidistant of the outside. And as you can see, let me see if I can do it just by, you can create the inscribed angle. Okay, so inscribed angle, it means it's gonna be inside of the triangle. Okay, so have fun.